Okay, in our last stoichiometry, part 1 in the series, we looked at mole to mole relationships. In this one, we're going to be looking at mole to gram and gram to mole relationships. But first, we need to do just a little bit of a review, and that is how to determine the molar mass of a compound. So let's take a look at this one right here. It says to determine the molar mass of a compound, such as potassium chlorate, KClO3, simply add up the atomic masses of the elements which make up the compound. We now know that KClO3 is composed of potassium, chlorine, and 3 oxygen atoms. So from the periodic table, we'll simply look up those masses, those atomic masses. For potassium, 1 mole weighs 39.10 grams. We'll go to the nearest hundredth of a gram. Chlorine is 35.45, and we have 3 oxygens, which are each 16.00 for a total of 48. When we add those up, we get a total mass for potassium chlorate of 122.55 grams. So 1 mole then of potassium chlorate weighs 122.55 grams. I know you knew this from before, but I just wanted to review just a little bit because we're going to be needing that technique in just a few minutes. So let's take a look at how we go about going in a balanced reaction in a stoichiometric relationship from grams to moles or from moles to grams. Let's take a look at this problem. Here's what it says. It says, how many grams of potassium chlorate, so this is the reaction that we just looked at, how many grams of potassium chlorate are required to produce 8.25 moles of potassium chloride? So the first thing we need to do is we need to make sure that the equation is balanced. We have 2 potassiums here, 2 potassiums there, 2 chlorines here, 2 chlorines there, 6, that's 2 times subscript 3, 2 times 3 is 6 oxygens there, 3 times 2 we have 6 oxygens there. It's a 2 to 2 to 3 mole to mole to mole relationship. Now they tell me in the problem that I want to produce 8.25 moles of potassium chloride. 8.25 moles of potassium chloride. So I'll write that directly underneath in the reaction the potassium chloride, 8.25 moles. And we're looking for how many grams of potassium chlorate, grams of potassium chlorate. So I'll put question mark grams because that's what I'm looking for. I'm looking for the number of grams of potassium chlorate. Now notice, if they were asking me for the number of moles of potassium chlorate, it'd be an incredibly easy problem, because if 2 moles of potassium chlorate decompose into 2 moles of potassium chloride, and if I end up with 8.25 moles over here, I would have had 8.25 moles over here. But it's not going to be quite that simple, because we're going from moles to grams. All right, let's take a look. We're going to copy what we know, 8.25 moles of potassium chloride over 1. Times whatever unit is here, I'm going to copy here. So that's moles of potassium chloride. Whatever unit I want is going to go right there. But I can't go from moles of potassium chloride to grams of potassium chlorate. I have to do what we call a mole to mole bridge. This unit right here is called a mole to mole bridge. And I get the components of the mole to mole bridge from the balanced reaction. 2 moles of potassium chloride are produced from 2 moles of potassium chlorate. That's from the balanced reaction. 2 moles of potassium chloride produced from 2 moles of potassium chlorate. So I simply write 2 and 2. Now you may say, well, isn't that a wasted step, since 2 moles divided by 2 moles is simply going to cancel? Well, it's just part of the protocol. The problems will get more difficult later, and it'll be necessary to have this step in place. So we want to maintain consistency. So go ahead and do the step, even though you know that 2 divided by 2 is 1. I'll cancel this unit with this unit. I'm left with moles of KClO3. The next thing I'm going to do is I'm going to ask again, is that what I'm looking for? No, I'm looking for grams of KClO3, so I need another step. This is a step above and beyond what we saw in the first 2 questions of the series, where we were going from moles to moles. So what I'm going to do is I'm going to continue on. Times whatever unit is here is going to go right there, and whatever unit I want is going to go right there. I'm looking for grams of KClO3. So how do I determine the number of grams of KClO3 in 1 mole? Well, we just did it. What we did was we added the atomic mass for potassium, the atomic mass for chlorine, and 3 times the atomic mass for oxygen, and we got this number 122.55. grams. So 1 mole of potassium chlorate weighs 122.55 grams. I'll cancel this unit with this unit, and I'm left with grams of potassium chloride. I'll ask myself the question, is that what I'm looking for? And the answer is yes, absolutely. I'm looking for grams of potassium chloride. I'll look back here, and I can see that's what I'm looking for. So I'm done. Now, there's no need to deal with the 2 and the 2, as we've said before, because they're going to cancel. So I'm simply going to multiply 8.25 times 122.55, and what I get is 1011.0375. That's what shows up on my display screen of my calculator. But I can't take all those significant digits. I have 3 significant digits here. These don't count because they're exact. The 1, the 2, the 2, and the 1 are exact numbers. I have 5 significant digits here. I can only have a total of 3 significant digits. 3 significant digits, so I'll underline the first 3. Now, when I write 1011.0375 to 3 significant digits, look what happens. I have 1, certainly that's significant. That 0 counts because it's trapped between 2 non-zero digits, 1, 0, 1. But I can't stop there because of the fact that this is not 101, it's 1011. So I have to place another 0 to hold a place, but do not write a decimal here to the right of the 0 because that would render that 0 significant. I don't want 4 significant digits, I only want 3. So my final answer would be 1010, without the decimal, grams of KClO3, grams of potassium chlorate, and I'm done. And I'm finished. All right, so that's going from moles to grams. Now let's go the other way. Let's go from grams to moles. It's exactly the same technique. Here we have a problem that states this. It says that iron reacts with chlorine gas to form iron 3 chloride. How many moles of iron 3 chloride are formed from 12.4 grams of chlorine? Again, first we have to write a balanced reaction. 2 moles of iron on the left-hand side, 2 moles of iron on the right-hand side. Be careful with chlorine. 3 times 2, that's a total of 6. 2 times 3, that's a total of 6. So I have a balanced chemical reaction. It's a 2 to 3 to 2 mole to mole to mole relationship. Again, that's 2 to 3 to 2 mole to mole to mole relationship. Now, what are we given? We're given 12.4 grams of chlorine. So I'm going to write 12.4 grams directly under the chlorine. What about the iron chloride? The iron 3 chloride, that's what I'm looking for. How many moles? We're looking for moles of iron 3 chloride. So I'm going to put question mark moles directly under the iron 3 chloride. Okay? The next thing I'm going to do is this. I'm going to write down what I've circled. 12.4 grams, that's 12.4 grams, over 1 times whatever unit is there goes there, and whatever unit I want is going to go on top. Now, I can't go from grams of chlorine gas to moles of iron chloride, so what I'm going to have to do is I'm going to have to go through moles of chlorine. So whatever unit is there goes there. I now know the number of grams of chlorine in 1 mole simply by adding the molar mass or the atomic mass of chlorine, doubling it. 70.90 is the total, and I get 1 mole of chlorine gas is 70.90 grams in mass of chlorine. That cancels with that, and I'm left with moles of chlorine. I'll ask myself, is that what I'm looking for? No, that's not what I'm looking for. I'm looking for grams of chlorine, or excuse me, I'm looking for moles of iron chloride, so I'll need another step. So moles of chlorine and moles of chlorine cancel, and I'm doing a mole-to-mole bridge. 2 moles of iron chloride are produced from 3 moles of chlorine gas. There's my mole-to-mole bridge to get me to moles. I'm looking for moles of iron 3 chloride. And now I'm ready to calculate because that's what I'm looking for, moles of iron 3 chloride. So I'll say 12.4 times 2, enter, divided by 70.90, enter, divided by 3, enter. And when I do that, I get this number, 0.1165961. That's a lot of digits. I can only have, though, let's see, I have 3 here, I have 4 here. These don't count because they're exact. I can only have a total of 3 significant digits. The first one doesn't count, so I'll just go ahead and do this. 0.116. The 5 is big enough. Anything 5 or bigger kicks the 6 up to a 7. So I have 0.117 moles of iron chloride, and I'm done. And I'm finished with this video podcast. We're going to be looking now at gram to gram relationships. So we've looked at mole to mole relationships in the first video podcast of the series. Then we looked at mole to gram to mole in this video podcast. And now we're going to be taking a look at gram to gram relationships in the next video podcast. I'll see you there.